My name is Johnatan Ivanov. I'm 21 years old, a senior at the University of Pittsburgh, applying to vet school this summer. There I am. And today I'll be taking you through my solutions for problems 19, 20, and 21 for Project 1 of Math 1020. And I guess it doesn't let me show the top of my Mac, so here is the current date and time, August 15th, and if I open my calendar, you can see 2024. It is indeed August 15th today. So now I will take you through my answers for problems 19, 20, and 21 for Project 1 for the class Math 1020. Okay, so all of these deal with this equation right here, this function, f of x equals rx times the quantity of 1 minus x, and then we are given differing values of r, and at which we'll put through separate programs to run iterations, and yeah, these are my answers for that. So in this first problem here, we're given an R value of 3.2. We'll put that into the first program, and it'll run an iteration 49 times. And as you can see here, pretty early on, it will catch the scent, if you will, and get on these repeating values of around 0.513 and 0.799. And then from there, it'll pretty much oscillate between those values for the rest of the iteration. You can see that represented nicely here with a pretty clean graph. And then so just putting that out in words. Does it converge? Yes. Is it periodic? Yes. And then it is periodic on these cycles, or on these values of 0.513 and 0.99, and it converges on these values as well. And then I like this program as well, just for a little bit of a better visualization, to see the periodic cycleness of it, and you can really see how it's oscillating pretty steadily, well, completely steadily, just between these two values. And again, got a nice clean graph right here. So moving on to the next problem, instead of 3.2 for an R value, we get 3.5, and we'll see how the iteration or how the programs tackle this. So a little bit messier here. I initially thought that this wasn't periodic at all until you get down farther into the cycle, where it really starts to just kind of stay put on 4 repeating values. And it just kind of goes through those over and over again. So it does eventually get to be periodic, but it does take some time, only towards like kind of the end of the 49 step iteration. So just to have that written out, it still doesn't converge, but it is periodic, and it is periodic on these values. I think it's arbitrary where you start it, but the values in any order, in this order, 0.875, then 0.38, then 0.82, and then 0.50. And I mean, like, I'm saying that you can start it on 0.50 up front here, and then it'll take you down the line. Or you can start it here, and then it'll take you down the line. But so it's arbitrary where you pick the cycle to start, but this is where I chose. And then here, a little more chaotic than the last time, but eventually you can kind of see how it stabilizes, where we're getting the same values over and over again here towards the end, and then you can see kind of the graph start to tighten up. Pretty. It takes a minute. Like there's still quite a bit of oscillation down here, but eventually it does stabilize into that cycle. And then now for something totally different, we'll go to the next problem, problem 21, where our R value is 4, and then it is mass. So yeah, so there's no convergence of any points. The iteration is just kind of running riot, and yeah, so I mean it's completely messy. It's all over the place. There's no convergence or cyclicity or really anything, and so I have that written out here. And then, like I said, great way to visualize is with this next program. Yeah, you can see. I mean, it is just all over the place. So yeah, no convergence or any periodic values here, and that's kind of it. Yeah, the 4 different versions of the functions, they all behave differently under the iteration, and these 2 programs were a pretty neat way to visualize that. So that's it.